Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to do our final notes on Section 3, solving equations with a variable on both sides. And what we're going to focus on today is special cases that can occur when we solve an equation with variables on both sides. There are two special cases when you solve equations. The first special case results in having infinitely many solutions, whereas the second special case will result in something called no solution. So we want to take a look at what will result in these two special cases. So when you solve an equation, if the variables cancel out completely, for example, you take 7x and you subtract 7x, and that happens on both sides, then you'll have one of two options left. You'll either be left with a true statement, such as 5 equals 5, and that means that there are infinitely many solutions to our problem. So basically, any number works. However, if we result in a false statement after our variables have canceled out, such as 7 equals -2, well, since 7 is not the same thing as -2, that would be no solution, which means there is no number that would work for this problem. So we're going to go take a look at a couple examples now so you can see exactly how this works. Our first example is 4x plus 6 equals 2 times the quantity 2x plus 3. So when I solve this equation, I'm going to solve it just like I would any other equation. I'm going to draw the line down the equal sign, and then I'm going to work on distributing the 2 on the right hand side to get rid of the parentheses. So on the left we would still have 4x plus 6, and that's going to equal, when I multiply out the 2 times 2x is 4x, and 2 times 3 would be 6. And then I want to work on getting my variables on one side. So I have 4x and 4x. They're the same, so I'm just going to pick one and do the opposite. So I'm going to subtract 4x on both sides. Well, when I subtract 4x on both sides, on the left the 4x's cancel. I'm left with 6. And on the right, the 4x's cancel, I'm left with 6. So since my variables canceled out completely in this problem, I want to take a look at the final result. 6 equals 6. And I want to ask myself, is that a true or false statement? Well, 6 equals 6, that's true. And anytime it's a true statement, once your variables have canceled out, we call that infinitely many solutions. In other words, we could plug any number in the world in for x, and this equation would be the same on both left side and right side. So infinitely many solutions is our answer. Our second example is 6x minus 5 equals 2 times the quantity 3x plus 4. To solve this problem, again, we're going to solve it like a normal equation. On the right, we're going to distribute the 2 to both the 3x and 4. So on the left, we drop down 6x minus 5 equals, and on the right, 2 times 3x is 6x, plus 2 times 4 is 8. Now at this point, I want to get the variables on one side. So I have a 6x and a 6x. Doesn't really matter which one I move. I'm going to need to subtract 6x on both sides though, because they're both positive. So when I subtract 6x, on the left they cancel. I'm left with a -5. And on the right, the 6x's cancel, so I'm left with an 8. Now, When this happens, your variables are gone completely. You want to ask yourself, am I left with a true statement or a false statement? -5 equals to 8 is a false statement. Last I checked, -5 is not the same thing as 8. So when you get a false statement after the variables have canceled out, we call this no solution. That means that there is no number that we could plug in for x to get this equation to work. So no solution is our answer. It is time for your first U-try. Please pause the video and attempt the problem t minus 27 equals negative times the quantity 27 minus t. When you have an answer, resume the video to check it. For this problem, what we're going to do is we're going to start by distributing the negative on the right side of the equals. Now remember, if there's just a negative outside the parentheses, we assume that's a -1. So we're essentially multiplying -1 with 27 to get -27, and then -1 with the negative t to get a positive t. We have -27 plus t on the right, and then on the other side I'm just going to drop down t minus 27. So when I do this, I now want to get the variables on the same side. So we're subtracting t on both the left and the right. T minus t cancels out. We have -27. On the other side we have -27, and the t's cancel. So this says -27 equals -27. So again, when the variables are completely gone, they all canceled out. Is this true or false? -27 is the same as -27. And when it's true, remember we call that infinitely many solutions. So again, that means that you can plug in any number and it'll work to solve this equation. So any real number is a solution. It is now time for your second U-try. Please pause the video and attempt the problem 16 times the quantity 4 minus 3m equals 96 times the quantity -m over 2 plus 1. When you have finished solving, resume the video to check your answer. To solve this problem, the first thing we're going to do is distribute the 16 on the left side of the equals. So 16 times 4 and 16 times -3m. 16 times 4 is 64. And 16 times -3m is -48m. Now if you didn't know those numbers on the top of your head, just multiply it out off to the side. On the right hand side, we're going to distribute the 96 to the fraction -m over 2 and to the positive 1. Now remember, when we multiply whole numbers with the fractions, what we are essentially doing is dividing and then multiplying by the numerator. So 2 goes into 96 48 times. And 48 times -m would make this -48m. And then of course 96 times 1 would make this plus 96. Now once we've distributed, now we're going to get our variables on the same side. So I have a -48m on the left and a -48m on the right. So on the left, the opposite of a -48m would be a positive 48m. And what you do to one side, you have to do to the other side. So what we have here, the 48m's cancel. We have 64. And on the right, the 48m's cancel. We have 96. So remember, when your variables cancel completely, you want to ask yourself if you are left with a true statement or a false statement. 64 equals 96. 64 is not the same as 96, so this would be false. And anytime the variables cancel out and you have a false statement, we call that no solution. So this means there is no number that we could use to get this equation to work. So no solution is our answer. This concludes our lesson on solving equations with a variable on both sides, part 3. If you have any questions, please ask Miss Brooks. Thanks for tuning in, and we'll catch you next time on your Daily Dose of Math with Miss Brooks.